Assalamualaikum. This is Chemistry 11th, and our today's lecture is about long form of periodic table or modern periodic table. Dear students, we have already discussed this Mendeleev's periodic table. So it was then because of it was demeritus this Mendeleev's periodic table. It was discarded, and it was then Henry Moseley in 1913. He was an English physicist. He was from England who studied that the frequencies who studied the frequencies of X-rays which were emitted when certain metals were bombarded with high-speed electrons. He found that in all the cases the square root of the frequency was directly related to the atomic number of the metal atom, and it was not to the atomic mass. He found that there was no correlation between frequency and the atomic mass of the metal atom. Now, actually, what he did, he plotted a graph between this square root of this frequency and the atomic number of different metals, and got and straight lines were obtained for these different metals if frequency was plotted against this atomic number. But this was not the case when he plotted the graph between this frequency and the atomic mass. So these studies they led Moseley to believe that it is the atomic number and not atomic number which is the fundamental property and not the atomic mass. So he based his system of classification on this atomic number. Now, we know that this atomic mass, it is the sum of protons and neutrons that are contained in the nucleus, because both protons and neutrons, these particles, they are contained in the nucleus, and these have nothing to do with the chemical properties of the element. Now, we know that these chemical properties of the elements, they are related to the atomic number, that is the distribution of electrons in different shells. Now, the elements with different electronic configurations will possess different chemical properties. Since the number of electrons, it is given by the atomic number and not atomic mass, therefore this atomic number should be the basis of classification of elements in periodic table. And it was on the basis of this atomic number, Henry Moseley, he put forth his periodic law, which is stated as the properties of the elements are the periodic functions of their atomic numbers. I will repeat, the properties of the elements are the periodic functions of their atomic numbers. That means if the elements are placed in increasing order of their atomic numbers, the elements with similar properties will be repeated after regular intervals, or I would say the elements with similar properties or I would say the same electronic configuration gets repeated in a group after a gap of this 2, 8, 8, 18, 18, and 32 elements. So the same these chemical properties, they get repeated after regular intervals, or the same outer electronic configuration gets repeated after regular intervals. Now, as far as this periodic table is concerned, we see that the vertical columns of this periodic table, they are called as the groups, and the horizontal rows, they are called as the periods. Now you can look here, there are seven these horizontal rows: 1, 2, 3, 4, 5, 6, 7. So these are called as the periods, while as there are 18 vertical columns which are known as the groups. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Now, in the earlier arrangement of this his Moseley's this periodic table, the groups were these were the groups were arranged like this: first A to 7A, then we have got first B to 7B, and then we have got the 8th group and the 0 group. But according to International Union of Pure and Applied Chemistry, that is IUPAC, now these groups have been now designated designated from 1 to 18. Now in this periodic table, there's unlike this Mendeleev's periodic table, we see groups are independent and they are not divided into sub groups. Now, as far as the characteristics of the groups are concerned, we have got these as groups are these are the vertical columns. All the elements in a group have the same general electronic configuration. Okay, configuration. For example, alkali metals, we can see the first group. Alkali metals, including this hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. They have got one valence electron in their outermost shell, and they have got since the chemical properties are related to the outer electronic configuration. So this family are these alkali metals. They have got the same chemical properties. Now the elements in a group, we can see here elements in a particular group, they are separated by a definite gap of atomic numbers. You can see hydrogen and lithium, there is a gap of 2 elements. Similarly, lithium and sodium, there is a gap of 8 elements. Again, 8 elements. So there is a gap of 2, 8, 8, 18, 18, and 32 elements. Now, atomic size, as far as the atomic sizes of the elements are concerned, the atomic size of the elements, it increases as we move down the group, because new shells, the size of the atom increases because new shells get added to the same atom, to the atom. Now, then we see that the physical properties of the elements, like we have we have got density, we have got melting point, as boiling point, as solubility, etc. They follow a systematic pattern. Now the elements in each group have similar chemical properties. I will repeat, because they have their chemical properties, they are related to valence shell electronic configuration. So in a particular group we have the same valence electronic configuration, so chemical properties will be similar. If you look at the group second of the periodic table, we have got beryllium, magnesium, calcium, strontium, barium, and radium. They have got two valence electrons, so outer electronic configuration is the same, that is ns2. So obviously their chemical properties would be similar. Then if we look at 13th group, we have got boron, aluminum, gallium, indium, and thallium. They have got 3 valence electrons and chemical properties would be same. Similarly, in 14th group, we have got 4 valence electrons, and in 15th we have got 5 valence electron, and in 16th group we have got 6 valence electron, and in case of this 17th group we have got 7 valence electrons. So then we have got the 8th group, which are their outer electronic configuration. They have got stable configuration, because their outermost shells are completely filled. So this is about groups. Now, as far as periods are concerned, I have told you that these are the horizontal rows of the periodic table, and we have got 7 periods. Now there are 7 periods. I have told you that in long form of this periodic table, and these periods, they differ with respect to the number of elements present. Now, in fact, there is a correlation between the periods and the energy shell of the and the energy shells for the electrons. Now periods represents the period, and now in case of the period, the number corresponds to the principal energy level. That is the main energy level. That is n, or it is given by the principal quantum number. Now I have already told you about this. Now the first period, we have seen here there are only 2 elements. You got hydrogen and helium. It is called the shortest period. Now, as far as the second and the third period are concerned, you can see here we have got 8 elements each. These are called as the short periods. Now, then we have got this period number, this fourth and fifth. They have got 18 elements each. They are called as the long periods. While as this the sixth period, it consists of 32 elements. It is called the longest period of the periodic table. Then we have got this seventh period. It is the incomplete period, because some of the elements at the time of this Moseley, they were not discovered at that time, so they were not known. So this is called as the incomplete period of the periodic table. Now, as far as the characteristics of the period are concerned, we have got in all the elements present in a period, the electrons are filled in the same shell. See, this is the first shell, this is the second shell, third shell, fourth, fifth, sixth, seventh shell. So elements are filled in the same Same shell. The atomic size of the element it generally decreases as we go from left to right in a period, because electrons get progressively filled in the same shell. So size gets decreased. Now also in period the metallic character of the elements also decreases as we move from left to right, because on the left side we have got the metals, and on the right side we have got the non-metals. Now also this electronic configuration changes. As electronic configuration changes as we move from left to right, because here you have got one valence electron, then you have got two valence electrons, two valence, then three, four, up to the and up to the up to, you can see in case of lithium we have got one valence electron, beryllium we have got two valence electrons, then you have got three in boron, 4, 5, 6, 7, and in neon we have got 10 valence electrons. So valence electrons get progressively increased as we move from left to right. Now as far as the this these lanthanides and actinides are concerned, these are two rows. There is no place at their proper position, so they have been put separately at the bottom of this long form of the periodic table. One series, that is of lanthanides, which is formed by filling of 4f level. So this consists of 14 elements. Then we have got actinides. This again this series consists of 14 elements, which is formed by filling of 5f level. Now as far as the first and the second groups of this periodic table are concerned, they are called as these are called as S block elements. So they represent the metals. Then we have got this P block. This represents 13, 14, 15, 16, 17, and 18. That is zero group. This constitutes the P block, or these are called as the non-metals. So in between these we have got D block, which is starting from this group 3rd to the 12th. That is from, if we see with the first transitional series, that is scandium, titanium, vanadium, chromium, manganese, iron, cobalt, and nickel, copper, and zinc. So this series consists of 10 elements, which is formed by filling of D subshell. Now then we have got F block, which since F block it consists of these two series. We have got lanthanides and actinides. Since they have got no place at their proper position, so they have been put separately at the bottom of the periodic table. So these are the various features of this long form of the periodic table. Then as far as the division of this periodic table into blocks, that is S and P, D, and F block is concerned, I will tell you about these blocks in our next lecture. This is for today. Thank you very much.